around again, twice. So we spent 1 hour just rotating. That's a lot. Let h of t represent your height above the ground, measured in feet as a function of t. It means we have a function, it means we have a rule. Okay, that does the following. So every time t, that's my rule, it will going to associate to it the height, my height or your height above ground. How high we are above ground at time t. So this is h of t. So what the output is, so for every input, which is the time, we will associate h of t, which is the height above ground at time t. And at t equal to 0, I am down here. Okay, so we're going to understand this function, all of us, and we are going to try to graph this function. Are you with me? Okay, let's start. So my first question is, fill in the table below. What do I mean? That's time. And that's the height. How high we are. For every time, you have to tell me what the height is. So let us summarize. We're going to start here. We go around twice. It takes me 30 minutes to do a revolution. And the speed at which we're moving is constant. It means how much it travels is the same over the same period of time. So I start with you. If t equal to 0, what is your height? Now I start 0. Do you agree with them, with your classmate? Because why it is 0? Because he tells me that h is the height above ground. That's the ground level. H is how high. And we hope, it means t equal to 0, I am at ground level. So it means we're starting from here. Okay, that's where we start the Ferris wheel. Very good. Now, before I actually even answer all of it, let us understand a little bit the picture before I even go back to h. At t equal to 0, I am here. Let me ask you questions. When am I here? For which time I am up here? I'm not going to fill the table. I'm going to go back to the picture. So it takes 30 minutes to go around. So here I should be after 15 minutes because it's a constant speed. So we're going to move from here to here 15 minutes. Okay, so this is t equal 15. So at 15, I am up here. Very good. At what time I am here? So we're going to move this way, counterclockwise. That's how imagine I'm moving. All right, so we have a direction. At what time I am here? At 22.5, do you agree? Yeah. At t equal, where did I get the 22.5? Let us think a little bit. From here to here, 15 minutes. So if I go here, what this should be? 7.5, absolutely, 7.5 minutes, because that's my unit. So from here to here, 7.5, another 7.5, another 7.5, 22.5 minutes, that's where I am. And then I'm back up to the ground after 30 minutes. I finished my revolution. And then I'm gonna go again and do the same thing. So the height is gonna repeat itself. So let us fill in the table here. 7.5, it means when t equals 7.5, what is the height? Back to you. 200? Yeah, because this is the radius from here to here. From here to here is 200. And the output is the height. It means how high I am. How high I am is exactly 200. Okay. After 15, now that we understand the concept, what is the height after 15? It is 400. Very good. What's the height after 22.5? 200. After 30 minutes, quickly, I'm back down to 0. And then what's going to happen? 37.5 Of course, the picture is clear because this is at 7.5 and the same thing happened at 37.5. Mean when we add 30 minutes, we're actually going to repeat the process. So the output here, those two outputs are basically the same. They are starting to repeat their values. Now, 45 minutes, again, we're here also, because after 30 minutes, I'm back to the top. So when I start from here, after 30 minutes, a whole revolution, I am back up here. So this should be 400. It's the same as that, actually. The values are repeating. And then I left them blank because I want to ask you, what do you think I should put here? What's the pattern? What should be the value here, you think? Which value I'm after here? 52.5, basically I'm adding 7.5 every time because it's taking 7.5 minutes to go from here, quarter circle. So this is gonna give me a 52.5. So it's right here. So back again, I am at 200. And then finally, this should be 60 minutes. I'm back at back to 0. Okay, so these are the value of my height. Of course, there is a pattern. Values are repeating themselves every 30 minutes. It means the height is the same every 30 minutes. Now, part 2 is I'm going to sketch the graph of the height. All right, so now we're going to sketch the graph. So here, the input is time, which is in minutes. That's the time, okay? My output is the height in feet, okay? So time goes on the horizontal axis and the height will go on the vertical axis. Now I need to sketch the graph, right? So I definitely would like to keep, to have a certain scale. And from this table, we realize 0, 7.5, 15 are good numbers to take on the t-axis. So I'm going to take that point to be 7.5. This is 15, 22.5, and 30. And then I start adding the 7.5. So it's going to give me the 37.5, the 45, the 52.5, and the 60. Okay, so we're going to graph it very carefully. Now, what are the values? 0, something between 0 and 200, and then 400. So let me make this to 200. 1, 2, 3, 4, and this I'm going to make it to 400. Okay, so that's the scale I'm picking. And now let us sketch the graph. All right. At t equal to 0, the height is 0. At t equals 7.5, we are at 200. At t equals 15, I am at 400. At t equals 22, I am back to 200. And then I am back to 30. And then the values repeat. I am back to 200, back to 4, back here, and then back here. So those are the values I picked up from the table. Now we know that between t equal to 0 and t equals 7.5, that the height is increasing. So it starts at 0, and then the height increase up to 200, right? So we're gonna reflect this graphically. So we're gonna basically connect the dots. So the graph will go like this. Okay. The graph is gonna increase. It's gonna go like that. And then it's gonna keep increasing up to 400. Now between 15 and 22, the height starts decreasing because we're heading toward the ground. So it's gonna decrease. And then keep decreasing at t equal to 30, I am back at ground level. Okay, so that's really the idea of the graph. After that, what does the graph do? After that, the values are repeating themselves. It means whatever it's at 30, at t equal to 0, it's at t equal to 30. Whatever it is at t equal, let us say 3 seconds, it's going to actually repeat itself. So the value of the height repeats itself every 30 minutes. So basically, I'm going to take the graph and replicate it, the same thing, but shifting it because the values are repeating themselves. And that's 2 revolutions because we did a 2 revolution. So that's the graph of the height as a function of time. All right. Now, one of the main goals of this course is to find a formula for this graph. For this graph, it means, can I find a function, a rule, a formula that if I know the time, I know the height exactly. So one really of the goal of this class is, can I find a formula for this graph? That's one thing we will get to. Of course, this is not linear, definitely. So it's not a line. It's definitely not exponential. It's very different type of graph. Now, what characterizes this graph? What characterizes this graph is that the output values are repeating themselves. What do I mean by repeating themselves? It means the value at, let us say, 4 minutes. So if, let us say, the Ferris wheel is here at t equal to 4 minutes. Okay, so that's where I am. At t equal, after 30 minutes, it means at t equal 34. So we go, I make 1 full revolution. We're going back, the height is the same. So the height at 4, the height at 34 is exactly the same. The height at 5 minutes and at 35 minutes is exactly the same. So it means this graph, the output values are going to start repeating themselves. It means the output here at 4 and the output at 34 are repeating. So the output values repeat itself. Another thing is that if I take this graph between 0 and 30 and I shift it horizontally, take it and shift it, this piece of the graph and this piece of the graph totally coincide with each other. This type of graph, where the output value repeat, we're going to give them a name. And we are going to call them periodic function. So periodic function is going to be function whose graph basically repeat itself. Okay, and the period is going to be the time it needs to finish a whole cycle. So in this graph here, between 0 and 30, thus we can think of it a 1 revolution or 1 cycle. And after that, the graph starts repeating itself. So we're going to call this 30 minutes will be called the period. Okay, so what's a periodic function and what's the period? Well, we're going to define them, and then we're going to take lots of examples where we are going to find the periodic function and period. Okay, any questions before I move away from this activity? Back to you. Please ask questions because anything? Okay, so now what's a periodic function? I'm going to define it and then I'm going to work with it. Suppose f of t is a function. It means a rule. You have an input and you have an output. I'll give you an output. We're going to say that f is periodic if the output values repeat at regular interval. The function is periodic if the output repeat at regular interval. And the period is the horizontal distance required to complete a full cycle. So it's like the Ferris wheel. Give you an example. So the period is how long it takes to finish a revolution. So a function is periodic if the output values repeat, and the period is the horizontal distance required to finish a complete cycle. So I'm going to start with a bunch of graphs, And the first piece, I will do it. The second, it will be up to you to do it as a worksheet. So I'm going to take a bunch of graphs. And for each graph, the question is the function periodic, yes or no? And if it is periodic, what is the period? It means how long it takes for the graph to complete a full cycle. Okay, so I will start and you guys will help me. Can you see very well the graph in front of you? Yes or no? Yes, yes, very good. So the first graph, do you think this is the graph of a periodic function? It means, are the output values repeating? Or in other words, if you take a piece of the graph and you translate it, does it a certain distance? Does it overlap with the other part of the graph? So everybody's telling me periodic, because let me see, if I start from here, watch carefully. I go up, the graph goes down. And after that, is it repeating? It means, are those output value repeating? If I take this piece of the graph, translated by 4, those two are totally overlap. If I take this piece of the graph, move it, it will overlap with that. Okay, so this is a periodic function. It means those values are repeating. The output value are repeating. So what is the period? The period is how long it takes to finish a cycle or to start repeating itself. If I start at 0, go up and down, then I realize that the graph starts repeating itself. So the cycle here, that's one cycle. And then between 4 and 6, again, that's another cycle. Okay, you can think of this as another cycle. And what is the period? The period is how long it takes to finish a cycle. And the period here is 4. The period is 4. Let me write it in better color. All right, so the period here is equal to 4. Now I'm going to move to another graph. Sorry. It's equal to 4. Okay, now I'm going to move to another graph. Again, I would like to ask you, graph number 2. Is this a periodic function? Yes or not? It means, are the output value? No, no, no. Everybody's screaming no. Everybody is right. Because if I take the graph from here to here, for example, I know the shape is the same, but the output are not the same. If I take this graph and shift it a little bit, those two do not overlap. Okay, so the output values here are definitely not repeating, even though the graph look like a bunch of triangle connected to each other, but if I switch this, put it here, definitely do not overlap. There is no overlap. The output values are not the same. So this is definitely not periodic. Not periodic. All right. 2 more graphs. Okay, because you have to have a picture in your mind when you hear the word periodic. It means function that repeat their values. Okay, so this is the graph. Do you think this is periodic? Okay, so let me start here. You can start anywhere to check whether it's periodic or not. I start here and I start moving along the graph. I go down here. When I hit that, I realize then the output are starting to repeat themselves. 0, 6 is the same. 1 and 7 are the same. So the output are starting to repeat themselves right here. So stop, and then they repeat themselves. So up to here, from here to here, I have one cycle. This is one cycle. And then after that, up to here, that's another cycle. The values start repeating themselves. So this is periodic. And what's the period? The period is how long it takes to finish a cycle. So the period here is 6. Okay. that's a periodic function. Very good. Now, to find the period, let me make a comment. You don't have to start at 0. You can start anywhere and ask yourself how long it takes to repeat. So for example, if I start at 3, let me start at 3. I can start here, go down, up, down. Then I realize that the graph starts repeating itself here. The period is from 3 to 9. From 3 to 9 also you have 6. So to find the period, you don't have to start at 0. You can start at any point, check the graph, and stop when you realize that you start repeating your output. So if I start at 3, up, down, up at 9, so I look at this piece, and then I realize, after that, we are repeating. The output are repeating. The output are repeating. All right, one more, and then we proceed. The last graph. What do you think? Periodic, not periodic? Again, everybody tells me it's periodic. And let us see how does it start to repeat itself. Okay. Again, I'm going to start here. And I keep going till I realize the graph is repeating its value. So I'm going to go up. So I keep going and thinking. And then I go up to here. And then I realize after that, it's repeating. It means if I take any output here and here, those are the same value. And then it's go back, down, now start repeating, and so on and so forth. So this is a cycle here. Sorry, if you don't see, you have to tell me. Like sometimes I put my finger where I shouldn't, in a place where I hide what I'm talking about. So let me know. So that's one cycle. So let's see, how much is the period? What's the period here? Do you guys see it? Anybody see the period? How long it takes? 10. The period is equal to 10. So we can basically take a ruler if you want and kind of see, okay, from here to here, that's my ruler, is equal to 10. That's a cycle. From here to here, I have 10. That's the cycle. All right, that's really what the period, how long it takes to start repeating itself. All right. Now, part 2 is, whenever we have a periodic function, we talk about 2 things. We talk about midline, and we talk about amplitude. Okay, and slowly, we will try to give a physical meaning to that. But first, what is the midline? Now, of course, I will define it for you, and then we work with it. So what is the midline? The midline is a horizontal line that is midway between the maximum and minimum value of the function. So it's a line located halfway between the maximum value and the minimum value of the function. And the amplitude is the distance between the midline and the maximum. Okay? Now we're gonna try to understand every word I wrote here. So what's the midline and what is the amplitude? I'll go back to my graph, and for each one of them, I will find the midline and the amplitude. I do the first, and you guys will help me with the rest. So what's the midline? So the first one is simple. The midline is a horizontal line. So it's a line. And midway between the max and the minimum value of the function. So this is here my function. So this is my x value, and these are my y value, all right? And the midline is the line halfway between the max and the min. So what's the maximum value here of this function? I know this is easy here. The maximum value, it means what's the maximum value obtained by the function? 2. That's the max. What's the minimum value? Is what's the smallest value that the output have. The smallest value the output have is 0. It doesn't take anything. The minimum is 0. What's the midline? The midline is a line. It's a horizontal line. It's halfway between the max and the min. So halfway, because that's a very simple scenario, I don't need any formula. It means right there. That's the midline. It's a line. Be very, very careful. It's a line. So it is a line. That's the line. That's the midline. Okay, it's halfway between them. So that's the midline. Okay, so what's the equation of the midline? Remember, it's a line. A line have an equation. So the horizontal line, its equation is y equal to 1. Now, not 1, y equal to 1, because it is a line, not just a number. Now, what's the amplitude? The amplitude is the distance between the midline and the max. So once we draw the midline, which is easy, the amplitude is from here, from the midline to the maximum value. That's the amplitude. Okay, so that's the amplitude. The amplitude in this case is equal to 1. So it's the distance between the maximum value and the midline, which is equal to 1. So the amplitude here is 1. Okay, so the midline is a line, y equal to 1. Amplitude is how far we are from the middle to the top, how far we are from the middle to the top. Okay, so we're going to take every example I took before and find the midline and the amplitude. Now, second example was not periodic, forget it, there is no midline and there is no amplitude there. Now, the third example is here. All right. Again, I need to find the midline and I need to find the amplitude. So first, the midline is the line halfway between the max and the mean. So I always start by figuring out what's the maximum value of the function and what's the minimum value. The max, it means what's the highest value the output takes. So what's the highest value? Everybody is telling me 4. That's my highest value. The minimum is the smallest value the function take. All right, what's the smallest value? If this is right here, -4. So that's the max right there, and that's the mean. Okay, still we are in simple scenario. What's the midline? It's the line halfway between -4 and 4. So what's the halfway between -4 and 4 is 0, right there. So this is the midline, halfway. That's halfway in between. So that's my midline. So midline is, it's a line. So you cannot tell me 0. What should you tell me? Instead of 0, y equal to 0, because it's a line, it's an equation. So the midline is a line, y equal to 0. What's the amplitude? The amplitude is the distance from basically the middle of the max and the mean and the maximum. So the amplitude is from here to here. That's the amplitude. So the amplitude, this is the amplitude. So the amplitude is 4 in this scenario. Okay. All right, I will do one more together and then I will give you a worksheet that you guys will have to do on your own, which is already on Blackboard, on Brightspace. All right, last one. It's a bit harder than the first two, but it's gonna even help us to find formulas. I mean, for the amplitude and the midline. Very good. So again, that's periodic. The period is 10. What's the max and what's the mean? I always start with that, so I know what I'm doing. What's the max? It means what's the maximum value? 20. Everybody is telling me 20, that's the max. So I'm going to really mark it down. So, all right, that's the max. And the minimum, even though it's not very well marked here, but the minimum is 5. Minimum is 5. With me? What's the midline? Now what's the amplitude? Okay, the midline is the line that is halfway between 20 and 5. Okay, so what is the halfway? Everybody's telling me 12.5, everybody is correct. So how can we find halfway? From 20 to 5, how many units do I have? 20 minus 5. So I have 15 units from here to here, correct? 15 units. So half of them is 7.5. So the half point here, so this is here, let me take. So from here to here, this is 7.5, halfway between them. Where did I get the 7.5 from? What I got the 7.5 is the following. I took the max minus the mean, which give me 15. Divided by 2, give me 7.5. It means from here to here, that's 7.5, which is basically the amplitude. And this is 7.5. And the midline is this line right there. That's the midline. So a lot of you can eyeball it, of course. So that's really the midline. So what is the midline here? Let us find the equation of the midline. This is 5. And from here to here, that's 7.5. So I will have 5 plus the 7.5. So this point is 12.5. Okay, so let us really recap. How did I find the 7.5? So that's the midline, 12.5. And the amplitude is the distance from the midline to the max. So that's my amplitude here. Which is 7.5. Okay, so I'm going to summarize again. Yeah, exactly. I'm going to summarize again. How do I find the amplitude? And I can give you a formula. If you want to use it, you can. If you don't want to use it, you want to eyeball it and find it out, also you will be my guest. But let me see how did we find the 7.5? What we did, we took the max minus the mean. What did this give us? How far apart from here to here I have. And then I divide this by 2 because I need half the distance for the max. So the amplitude, one formula for the amplitude is the following. It's basically you do that. You take the max minus the mean. When I take the max minus the mean, it means 20 minus 5. But then what did I do with it? To be able to get the 7.5, I divided by 2. This will give me the amplitude. So the amplitude here is basically the 15 divided by 2, which is 7.5. That's the amplitude. Now, what's the midline? You don't have to use formulas, believe me. How did we get the midline? The midline is the following. Watch carefully how we get it. It's the minimum. You add the 7.5 to it. So it's one way you can find it. It's the minimum plus your amplitude. That's from the picture. Okay. And there is another formula for it. I hate formulas, usually. Another formula is the minimum plus the maximum divided by 2, because this will give you halfway between 20 and 5. Okay. Let us summarize, max and mean. These are the formulas that you can use if you want to. You don't have to. It's really up to you. For me, I actually like to eyeball them. Whenever I have the max to find the amplitude and the midline, first I find what's my max, what's the mean. This is the max, and that's the mean. To find the midline and the amplitude, I need the halfway through. So I ask myself, okay, what's the distance from here to here? If this is 20, this is 5, so that's 20, take away the 5, that's where this is coming from, divided by 2, this will give me the distance from here to here, give me the half point here. So that's 7.5, and that's 7.5. That's really the heart of it. Once I do that, the midline is this red line, and then I look at my picture. What's the midline? What's the equation? I have 5 from here plus 7.5. Let's give me the 12.5. And the amplitude is the distance from the midline all the way to the max, which is 7.5. So you can either eyeball it or you can use those formulas, whatever you're more comfortable with. And even if you use the formula, you have to go back to the picture. Ask yourself, am I making sense? Is this really the half line what I get here? You have really to make sense out of it. You're getting the midline. You have to know that those formulas will give you exactly the midline. And if you use them, realize they don't fit the picture, throw it away, and then start thinking about it a second time. All right, now what I would like you to do is the following. We're gonna practice those ideas. In the worksheet, which is on Brightspace, I want you to take up the second page and the third page. So all of you on Brightspace, again, I have the same ideas, but you're gonna practice them. So please, all of you, have them in front of you. That's the only way I can work with that. And the question here, determine whether each function is or is not periodic. If it is, you have to find the period, the midline, and the amplitude. The first two are fairly simple. The C is a bit harder. So let's get started. Please, I want your faces on the camera because it helps me. Please turn your camera on. A lot of you don't have it on. It's confusing for me. Thanks, Lucas. All of you, please. All right. Part A. Who's ready to answer? Periodic, not periodic. Okay, please try to get them. It's very helpful for me when you have your camera on. So everybody tells me it's not periodic. Not periodic. The output values are not repeating themselves, even though they look like the same, but no, if I start here, go back here, the values are not repeating, absolutely not repeating themselves. So this is not periodic. B, periodic, yes or no. I give you 3 minutes for all of you. Okay, all of you, every one of you. You have to answer periodic, find period, find the midline, find the amplitude, and then I will do it. Everybody's screaming, yes, everybody is right. I want the period, I want the midline, and I want the amplitude. This could be done just by eyeballing it. Okay, 2 minutes, and then I want the answer. Now, actually, I'm gonna pick one of you to give me the answer. I don't know who's gonna be my victim, but whatever. Yes, it is periodic, absolutely periodic. Okay, 2 minutes. I expect you to be working on it, okay? All right, I'm gonna pick one of you. I don't know you, so I'm not picking on anybody, just your luck. Daniel Olson, can you give us your input? Daniel, okay, periodic. The period is telling me it's 2. Let's see, make sure. If I start here, I go up, down, up, and then I realize it's starting to repeat itself. So this is a cycle. So periodic, the period is 4. The period is 4, not 2. Right? Do you agree with me? Is the period 4 or 2? What do you think? 4, because we start here. It's not repeating itself yet at 2. It starts, you keep going and going and start repeating itself here. So from here to here, you need 4. That's a cycle. So the period is 4. Now the maximum, I always want you to find the maximum and the minimum, even though I think your answer are right. The maximum is 2. And the minimum is -2. So the midline, also we have to draw it. It's halfway between. So that's the max and that's the mean. And halfway between -2 and 2 is definitely 0. So that's my midline. So the midline is y equals 0. And the amplitude is the distance between the midline and the maximum value. That's the amplitude right there. So it's equal to 2. Okay, so that's the amplitude. Very good. Now, C. Again, I'm going to give you 4 minutes to do C, each one of you, and then I will ask one of you the answer. Right. Okay. I'm going to pick one in an arbitrary way, as I said. Clarissa, are you ready? Are you ready? Okay, no problem. I'm going to give you 2 more minutes. I want you to take your time. If you're not, it means other students aren't ready either. Okay. All right, so we're going to look at the answers and we're going to check every one of them. So that's okay. I don't care about if you get them right or wrong. Not you, everybody. The idea is just I want you to work on them, and then if we not correct, we discuss them. So first the period. Okay, let me start. I'm going to start suppose I start here and I keep going and I stop when I realize the output are repeating themselves. So I look here, these are the output values, then not repeating, and then they are starting to repeat themselves. So how long it took for the graph to repeat themselves? So if this is 1, and should be 2, 3, and 4. So the graph seems that a cycle is taking 2 units to repeat itself. So that's a cycle. But after that, if I take this piece and I translate it by 2 units, it will totally overlap with that piece. So the period here is the cycle, how long it takes to finish a cycle. So my period here, oops. So my period, oh, none of them is working. The period is actually equal to 2. Okay, so that's my 2 here, and that's the period. So how long it takes. And then from here, back, that's another one. It's 2 units for it. Okay, is that, please, is it making sense? If it's not, let me know. Very good. Now, we want the midline and we want the amplitude. So I always encourage you to start with what's the maximum value that the function take? What's the minimum value? Right. It means the maximum that the function take. If I follow, this is 0, this is 1, and this is 2. So that's the maximum value that the function take. Okay, we have to start with that. So the maximum is 2. What's the minimum value the function taking? Okay, you guys feel free to write your answers on the chat when I ask. What's the minimum value? -1. Okay, so that's the minimum value. What is the midline? Okay, before I use any formula, we have to understand what is the midline. So that's the max and that's the mean right here. The midline is halfway between those 2 points. Now forget about a little bit math if you want. Forget about everything. How much do you have from here to here? How many units do you have between the max and the mean? Means from here to here. How many units do we have? Just by doing logic, we have 3 units. Okay, I'm not going to use the formula. I'm going to do 2 ways, with and without it, with and without it. So I have 3 units. So what's half of 3? It's a half, right? So I need 3 half from here and 3 half from here. So that's really the midpoints between them. Okay, so what do I mean by that? It means from here to here, how much do I have? Between this red line and this here, this dash, I have, no, 1.5. That's halfway. From here to here is another 1.5. And where is my midline? My midline is halfway, right there. So if from here, this is 2, this is 1.5, it means this point right here is 0.5. This point right here is 0.5. So my midline is going to be y equal 0.5, because this distance, this is 1.5. And what's my amplitude? It's how far the midline is from the max. So the amplitude is 1.5. Okay, so by looking at the picture, this is the max, this is the mean. The difference between them is 3 units. I need halfway between them. Half of 3 is 1.5. It means if I go from the top, 1.5 units, and then I can draw my line, I get the midline. Now, how about the math? Now I think, okay, it's from the bottom to here, that's 2. From here to here, it's a 1.5, so what's left here is 0.5. That's my midline. The amplitude is how far I am from the midline to the max, which is the 1.5. Now, I'm going to use the formulas to figure out the same answer. How does the formula work? Okay, I rewrite them, and then I will use the formula to figure out the max and the mean. The formula tells me that the amplitude is the max minus the mean divided by 2. Let us apply them in this context, which is equal to the max is 2 minus the mean is minus 1 divided by 2. Means is equal to 2 minus minus 1, it's a 3 divided by 2, which is 1.5, which is exactly what we got. Because what we're doing is the 3 here is the distance between the max and the mean. That's where the 3 coming from. When divided by 2, I'm finding half the distance between them. Now, the formula for the midline is, what I do is I take the minimum value and I add to it the amplitude. The minimum value is minus 1. The amplitude 1.5, which is 0.5, which is exactly what we got by eyeballing it. So I want you to be able to handle both. Either you can use the formula to find it, or you can actually eyeball it. And I know a lot of you can do both. All right? Okay, last one. And then we finish. Okay, I'll let you work on it for 3 minutes, every one of you, and then I will pick one. Okay, I'm getting some answers. No, we're doing D. We're doing D. That's the one we do. This you can do at home. This is easy. D. Okay, I'm getting an answer. So I'm getting a period 4. All right. Do you guys agree? All right, I'm gonna start, for example, here. I don't have to start at 0. I can start any point and see. Everybody tells me yes. And I can keep going and going and going and going till I start realizing that the graph is repeating. So when I hit this, I realize that the graph starts repeating. So you don't have to start at 0. And then okay, it's repeating. And how many units I have from here? 1, 2, 3, oh no, every 2, that's a 2 unit. So that's 1, 2, 3, 4, that's 2 unit. 1, 2, 3, 4, that's another 2 unit. So from here to here, that's a cycle. And this is equal to 4. Now the max. Before amplitude, I want the max and the mean. What's the maximum value the function have? Anybody? The max is 2. I think I agree with them. And what is the mean? The mean -8. Let me see. -5, -6, -7, -8. Very well. Okay, -8. Now the amplitude and the midline. So this is -8 and this is 2. With and without formula. First without formula. And then with the formula. How much do we have from here to here? How many units? From 2 to -8? 10. So from here to here, I have 10 units. So I'm doing it first without formula, then I apply the formula. 10 units. So half of 10 is 5. So the midline should be 5 units, either from 2 or 5 units from -8. It doesn't really matter. So I have 2 here. So that's where the midline should be. Sorry. Half of 10 is 5. So 1, 2, 3, 4, 5. So it has to be right there. So that's where my midline is. Halfway between them. Okay, so that's 10 units from here to here. Half is 5. The midline is somewhere, is halfway between them. So this distance here, which is basically my amplitude, this is 5 units here. If this is 5, 2, so this should be -3. So now I have the whole picture. My amplitude is 5, and my midline is y equal to 3. So midline, y equal -3, amplitude is 5. So we did that by actually eyeballing the whole picture. Okay, so between the max and the mean, I have 10 units. Half of them is 5. So that's what I am going. So 5 units. And I ask, okay, if I start from 2 and I go 5 units away from 2, 1, 2, 3, 4, 5, I ended up at -3. So I have 5 here and 5 here. So that's my midline halfway through. My amplitude is how far the midline is from the max. I'm getting a 5. Now I'll use the formulas and make sure I get exact the same answer. So the formulas now. Okay, the amplitude is the max minus the mean, which is gonna give me the 10 divided by 2. The max is 2 minus, the minimum value is -8. So this will give me 10 over 2, which is 5. Basically, we're taking the 10, dividing it by 2. That's my amplitude. Now what is, somehow I have a different graph. Oh, I don't, anybody has a, oh, don't worry about it. Or stick with me at the end of the hour and then I will check why you have a different graph. Everybody should have the same one. All right, so now the midline. Okay. So y equal the minimum value plus the amplitude. That's one formula for it. The minimum is -8. The amplitude is 5, y equal -3. Okay, and that's exactly what we have right there. All right, so of course that's it for today. Please go over those worksheets, make sure you can do them. And the homework is a lot of story problems like the Ferris wheel. So the homework for Wednesday is a lot of story problems, very much like the Ferris wheel, where you have to graph the function itself by yourself and then figure out the period, the midline, and the amplitude. That's it for today. Good luck for the semester. And as I said, if you guys ask me questions, show me your concern, we will make this a very pleasant semester. Any question before I let you go? Okay, so time is up. Giselle, if you want, you can, the worksheet is not a homework. The worksheet is for you to learn the material. Okay, so every time we come to class, most of the time I will have a worksheet that, you know, we work on it together so you can understand the material. All right. So number 3 on the worksheet, you guys can finish it and you do the homework that is already on Brightspace. Giselle, can you stick around? Tell me, what did you see? Okay, the rest can go. Bye-bye, guys.
So in the graph, I have horizontally, I have from -24 and then +24.
Okay, I changed this graph. Anybody else have the same issue? Because that was the original graph, but I've changed it. I wonder why you the only one who has it. That's interesting. Your graph is this one, right? Anybody has the same issue, those who are still there? Because that was the original one, but I've changed it. I changed it for the whole class. Anybody have the same issues that Giselle have? I guess everybody disappeared. No, it's weird. I don't know why you have that, honestly.
Oh, okay. Because probably yeah, you changed it, so I had to exit out then back at the worksheet again.
Oh yeah. I changed it because
Okay.
the number didn't make sense. After I printed it and saw, first I did it, but I didn't pay attention to the numbers. So when I printed it for myself to look at it, I realized the number were confusing for you guys.
Yeah.
I changed it.
Yeah, that makes sense.
Okay.
All right. Thank you.
Sure. Bye-bye. Anything
Bye-bye.
else?
No, that'd be all.
Okay. Bye-bye, guys. Then I will end the meeting.
Have a good one.